Okay, so continuing on now, we're going to change gears, shift gears a little bit. For those using this book, we're now going to be talking about some material over in Chapter 8, Section 1, right triangle trig, to introduce to you the 6 trigonometric ratios. And if I have time, this is going to be a short segment, maybe only 10 minutes or so today. And then if I have time today, I'll do a little solving of a right triangle using these ratios. And if not, we'll actually probably start the next class session off doing a little bit of right triangle solving. Okay? So here we go. If we draw any old right triangle, let me just draw a sample one here. We know there is a 90-degree angle in there. We also know that there are 3 angles in a right triangle, or in any triangle, 3 angles, and the sum of those angles have to add up to be 180 degrees, right? So let's call this angle over here on the left, let's call it alpha. Kind of looks like the fish I mentioned the other day swimming to the left. Let's call this other angle up here beta. Looks like a bee with a tail on it. Beta. Alpha and beta. Now you know from your geometry background that alpha plus beta has to then be how many degrees? 90 degrees, right? Because alpha plus beta plus our 90-degree angle in a right triangle, we know have to add up to be 180 degrees. If we subtract 90 from both sides, we see that the sum of alpha and beta is 90 degrees. We call alpha and beta what kind of angles, if this condition holds true? Complementary. Complementary angles. Each of those angles are indeed acute. They're less than 90 degrees, right? Those angles are each less than 90 degrees, and the sum of them adding to 90 indicates that each of these angles are complements of one another. So they're complementary angles. There's no I in there like, oh, you're a really good trig student, where I compliment you, right? That's different than complementary. So alpha and beta are complementary angles. Now, there are 3 sides, aren't there? I'm going to call this long side over here H, which you know is called the hypotenuse. How do you spell hypotenuse? Hypo, don't say it that way though. Hypotenuse, hypotenuse. Okay? Always try to be a good speller. Hypotenuse. The side opposite angle alpha, if you get inside here and look out, what you see opposite you over there is called, I'm going to call it letter A, small a. If I'm inside the triangle looking out from angle beta, I'm going to see an opposite side to it down here. I'm going to call that little b, small b. There are 3 sides to a triangle. And for the right triangle, there are how many possible ratios for these 3 sides? How many possible ratios?
6.
Yeah, ratio is a fraction, right? So there's 6 possible ratios. Now the Greeks set us up to have to memorize them in a certain order, those ratios. So if I take angle alpha and I look out from it and I see this opposite side over here, and I'm going to label it as such, opposite over hypotenuse, that's the first ratio the Greeks wanted us to become familiar with. The next one is the adjacent side to angle alpha is right here. This is the adjacent side. And I'm going to label that ADJ right here, and I'm going to label this one up here OPP, related to angle alpha. Adjacent to angle alpha is this side. So that's the second ratio, the adjacent side to the hypotenuse. Those are the two most important ratios for you to become familiar with. The Greeks define this as the sine, S-I-N-E, of this angle. Of this angle. And would it matter if I made this triangle larger or smaller but kept this angle locked in? Wouldn't the triangle still be similar? If I'm going to erase that. If I made this larger, say, aren't the ratios of that opposite side to that longer hypotenuse now still the same as this A over H? Yeah. Okay. So there's a scaling thing going on, but the ratios remain constant if you don't change the angles. If you don't change the angles. Okay. This is called the sine of angle alpha. This one is called the cosine of angle alpha, and the reason the co is there is because it's related to the complementary angle. Okay, and you'll see a relationship shortly. So looking at the numbers, or looking at the symbols we used up here, then this is going to be A divided by H, and this is going to be B divided by H. Now there's actually 6 ratios. The third important one is called the tangent, and we'll stick with angle alpha for a moment. And what tangent of angle alpha is it's something very familiar to you from your beginning algebra background. It's the slope of this hypotenuse line. The slope of the hypotenuse line is going to be opposite over adjacent, isn't it? Rise over run. Opposite over adjacent, or A divided by B. We have to memorize those definitions. Have to memorize those. Also, another thing for you to remember is look at what happens if I took this sine of alpha, which is a ratio, and I divided it by the cosine of angle alpha. In other words, this mess right here, sine alpha divided by cosine alpha, opposite over hypotenuse divided by adjacent over hypotenuse, what disappears in this complex fraction? Hypotenuse disappears, and we're left with, H disappearing, we're left with A over B. So if you take the sine of an angle divided by the cosine of an angle, it's going to be equal to the tangent of the angle. Okay. 3 important ratios. Now what if, now technically I'm going to kind of violate what I have written here regarding, don't look at this center column anymore. Think of the A's and the B's and the H's up here, and angles alpha and beta. If I was in here with angle beta now instead of alpha, what would be the sine of beta? Look at the trig based on definition. Opposite is this side divided by hypotenuse. B over H is the sine of beta. B over H is this thing right here. Right? So this is going to be the sine of beta. B over H. And up here, if you're here with angle beta, the adjacent side to angle beta is A, and the hypotenuse is up here. A over H is the cosine of beta. So the relationship you see between the complementary angles sits right here. The sine of alpha equals the cosine of beta. Sine of alpha equals the cosine of its complementary angle. And the cosine of alpha equals the sine of beta. Okay, that's confusing to most people. There are definitions you need to memorize. Opposite over hypotenuse is the most important one. Adjacent over hypotenuse is the next most important. And then the ratio of this one over that one is your tangent. Okay, I don't have time today to go on with an example, but what we'll start off next session with is an example. Okay, that ends today's class. Don't forget Friday, 11 to 12 in the math computer lab, room 222. Okay.